All seedlings require sunlight. Seedlings will become leggy and fragile and will not produce to their potential if they do not have sufficient light. Hi, dear learners! I am Teacher Josie and this is TVL Agri-Fisheries 12. So, prepare your pen and paper as we explore the theories in handling seedlings and planting materials. Handling of planting materials are very important in agricultural sector. Hence, learning the procedures in identifying the characteristics of a good quality seeds ensures you to produce quality product and has an economic benefit. In this lesson, you will be learning the different types of seeds, methods of seed testing, and computation of seed germination that you may apply.
The characteristics of a good quality seeds are the following. Damage-free. Damage-free seeds should be from physical or chemical damage that will affect its viability. Free from mixture. Seeds must be totally pure and no other seed mixture. Free from seed-borne diseases. Seeds coming from parents affected with the diseases will be down to its offspring and affects the whole population. And lastly, good vigor and germinating capacity. Select seeds that are viable, high germination percentage, at least 85%, and healthy. Before you sow seedlings, they must have the following characteristics. Healthy, vigorously growing and free of diseases. Robust with no deformities. Stem is sturdy and has a large root collar diameter. Crown is symmetrical and dense. Root system that is free of deformities. Have a balance between shoot and root mass. Leaves are healthy, dark green color, accustomed to full sunlight, and free from pests or diseases. There are also characteristics of quality propagules. In collecting propagules, the following should be observed in identifying quality materials. So, look at this example. This is a rose from cuttings. In cuttings, there are visible buds in stems and roots, healthy and disease-free stems, roots and leaves, and not too mature parts with visible drying of parts. Younger parts have faster growth than the mature one. For plants that are propagated by separation and division, source mother plants should be healthy and disease-free. For suckers, an example here is a tomato, and stolons like the strawberry, and other plants that can be separated should be mature enough to ensure success in growth. Buds eye are visible and with no damage. It should be planted immediately to avoid dryness or wilting. If transported, should be wrapped in a clean moist newspaper to prolong its shelf life. This is an example of a scion. Buds are healthy and no damage, disease-free from mother plant, from a source with desirable characteristics, and no deformities and size appropriate for the rootstock. Let's go back in your science subject, especially about seeds and its structure. Take a look at this picture. This is an example of a bean seed. Seed is a fertilized mature ovule, which consists of the three main parts, the seed coat, endosperm, and embryo, which in due course gives rise to a new plant. So the basic structure of a seed consists of the following. We have the seed coat, usually tough, and it's partly impervious to water. And we have also endosperm, stores food or starch, proteins, and etc. And the embryo, or miniature plant of the seed, consists of the cotyledon, epicotyls, and hypocotyls. Based on morphological characteristics, seeds are either monocot or dicot. Monocot seeds have embryo with single cotyledon, hypogeel in germination, leaf veins are parallel, roots are adventitious, and secondary growth is absent. For dicot seeds, It has an embryo with two cotyledons, usually epigynous germination leaf veins reticulated, and has secondary growth. In terms of crop production, these are direct seeded and indirect seeded, or what we call transplanted. Direct seeding refers to sowing of seeds directly in the permanent growing area. It is the most economical method of seeding. Indirect seeding is a method of growing of seeds in a separate place from which the plants will eventually grow to maturity. When it reaches the recommended seedling maturity, it will be transplanted one or more times before reaching the permanent growing area.
Seed germination is defined as the assumption of growth of the embryo, which begin in the process of imbibing water, increase of water content of seed, swells up, and then seed coat ruptures. But there are events that a seed does not germinate, even provided with the required conditions, and this phenomenon is known as dormancy. Seed dormancy refers to a state in which are a complex combination of water, temperature, gases, mechanical restrictions, types of seed coats, and hormone structures.
We have the types of seed dormancy. We have ecodormancy. Ecodormancy means due to unfavorable factor of environment or quiescence. Ectodormancy or paradormancy is correlated inhibition due to factors outside the embryo, except the embryo. Endodormancy, factors present in the embryo itself. We have methods of breaking seed dormancy: scarification, stratification, after ripening, light treatments, and treatment with growth regulators and other chemicals. Scarification, it is any treatment that removes the seed coat or alters it, making it more permeable to water, or cracking, breaking, scratching, rubbing with sandpaper, or soaking, and etc. For stratification, it is the placement of seeds between layers of either moist sand, soil, or sawdust at high-low temperature. This will soften the seed coat. For after ripening, it refers to changes in the seeds during storage because of which germination is improved. Some seeds do not germinate in dark, thus it provides continuous or periodic exposure of light is essential. Example is the lettuce or the Latuca sativa that requires red light or white light that is essential for germination to occur. And treatment with growth regulators and other chemicals. Endogenous dormancy may be due to presence of germination inhibitors. Application of low level of growth regulators such as gibberellins, cytokinins, or ethylene may break the seed dormancy.
Seed testing refers to the methods of determining the ability of the seeds to germinate. There are three methods of testing seed germination, and these are ragdoll, petri dish, and seed box.
The ragdoll method is a method of testing seeds using a towel. The towel is soaked and drained in water to facilitate germination of the seeds. We have also petri dish or plate method. Is a method of germinating seeds with the use of petri dish or plate and tissue. The tissue is moistened to facilitate seeds to germinate. And we have seed box. It is a method of germinating seeds in a small box, usually wooden materials, and which is a small version of a plat. Instead of tissue or towel, the seed box is filled with soil and moistened.
Now, we have the rules in computing the percentage of germination of seeds. Rule number 1. If you test 100 seeds, the number of seeds germinated equals the percentage germination of the seeds. Example: if tested 150 seeds of bitter gourd using the ragdoll method, 85 seeds germinated. The percent of germination of the seed then is 85%. Rule number 2. If you test less than or more than 100 seeds, use this formula in computing the percentage of germination of the seeds. Percentage germination is equal to number of seeds germinated divided by number of seeds tested multiplied by 100. An example here is number of seeds germinated is equal to 105 and number of seeds tested is equal to 125 times 100. So, 105 divided by 125 multiplied by 100 is equal to 0.84 or 84%. Thus, this means that the seeds did not meet the required percentage to become a quality seed. Rule number 3. If you found out that the percentage of germination of your seed is below 80, you need to adjust your seed bulk. So, adjusted amount seed is equal to amount of seeds needed divided by percentage germination multiplied by 100. Example, you need 150 seedlings for your garden. You found out that your seeds have only 75% germination. How many seeds will you sow? Let X the number of seeds to sow or your adjusted seeds. Given 150 seedlings and 75% germination. Therefore, X is equal to 150 divided by 75 multiplied by 100, and X is equal to 2 times 100. So, the product is 200 seeds. Seed or planting materials of a crop or a plant is a very important component in crop production. As good seeds interacts with good environment, determines the health of the crop or a plant. If the environment is conducive and the seed is poor, production is likely to be less. Hence, you must use good and healthy seeds and procure seeds from healthy sources. You should have knowledge of the local seed selection and conservation practices. Remember, improving agriculture improves lives. Again, this is Teacher Josie, and this is DepEd MP TV. See you on the next lesson.